very original idea to help people to enjoy the computer technology. So what is the EPC desktop OS capability? We want to keep this product with a high mobility, but it should be with very high reliability. Sometimes if people want to mobility, it's not easy to keep a reliability. How can we do that? So we not use the hard disk. We use the solid state. It means that it's a flash RAID disk. So you can keep people drop the computer on the ground. The computer still can run very well. And we must to let the user can very easy to enjoy the technology. Sometimes you want to keep the application easy, then you will lose the technology. We have to balance that. So keep the easy and the technology in the same application. It's actually it's not so easy job. And we want to let the people can still use this computer for their daily work. So we keep it to include application like OpenOffice. You can use the PowerPoint, Excel, and you can still use the email. Actually, those applications come from the open source. And instead of work, we still hope that people can keep a community. So this EPC is very easy to get you on internet. You can choose the mobile platform to let you to enjoy the internet and the mobility. And we still put some media and with the entertainment process. So in this EPC, you can play movie, enjoy the music, and play some MP3 music. So for the application, actually group size are the 4 groups. One is the internet. So every application about the internet, you can go to the internet tab. Then we put every application as a one item. For example, with mail. So you just click the web mail. You go to the Google Mail or the Hotmail. And then we keep the second thing is the work group, learn group, and play group. So in the work group, we put most daily operation you need application like OpenOffice or others. And in them, we try to bundle some education application on it. So this slide shows the Asus desktop OS cover user need. What are our applications from? First, we choose the Linux. We know that Linux actually is a very reliable OS. It can allow you to modify it as you want. So we choose the Linux kernel, and we use a Debian Linux distribution, and then we choose some application and modify that to be a Asus EPC desktop. So that is the process about the way how to choose the application. So this slide will give you a more detailed idea about the EPC. The EPC desktop is a multi-language platform. It's based on the open source Debian Linux and some other applications. So most applications come from the open source. So that's why we're here, and we want to share your experience about the open source experience. Actually, Asus also need to contribute something on open source. And we have integrated some commercial and some unique for EPC application. And we try to easy to develop for the EPC SDK and common program language and tool for development. That is the major target today I want to share you. If you have interest to develop EPC application, then how to do that. And we also support, in EPC, we also support applications in a runtime environment like Java or Adobe Flash. This slide is show the EPC OS stack. So from the ground, we have support some hardware peripheral and make sure the hardware platform can run very quickly. As you know, the EPC have different models. We have 2D models with 2, 5, 6 memory. Also have a 4D, 8D, and support more memory size. So we have to keep the system performance and the hardware limitation to get a balance is a big challenge for us. Just to take an example, if we use this 7-year-old server, it's actually a 2 GB, but only a 256 memory. How can you put a lot of application and then the runtime very quickly, and then you can reserve space for people to store their file they want. So it's a lot of technical you have to combine and to rethink it again. So from the scratch, we will have to address the hardware platform issue. Then we also have to build out the framework for the application. For example, we put the Mozilla Firefox, Java machine, and the Flash system, because more and more the user application actually need that framework. And we also preload some audio video codec to do some management, just in case the people want to put the movie or put the music, and then you can just easy plug and play it. And we also have to do the application package management. Why would we do that? Because we allow the people can through the internet to upgrade and to reinstall, new install, delete the application anytime. So we have to let the EPC client and work together with our EPC server. So we have to do the application package management. But we also include a human interface. A more special thing is this EPC supports speech recognition. So you can use a speech command to enable the application, not through your hand, you can through your voice. And we also need to do a localization. Everybody knows the open source is actually everybody's contribution on it, but sometimes it's not easy to support the localization. You have to do that by yourself. So for application, we have to translate the string to the local language. So we have to integrate it to that. And we also do something like cross OS platform and cross OS network management. We still think the people maybe use the EPC in office environment. So maybe you need to log in to Microsoft network or use a Microsoft file or file format. How can we do that? So we have to try to let the EPC can cross the OS platform and still can join the Microsoft network management. So we have to do something. Other things is like font management or agility support. And about the framework, that is the user application. Right now we put the application like the internet access, no matter it's a browser or the webmail. And we also integrate a Google service like a Google Mail or Google Document. We also put some internet TV, movie, radio inside. And we also support the instant messenger. Most application actually is from the open source, and we modify some. And we put a dictionary, email, ebook, and we also try to integrate a GPS plus a map service. More important thing is we want to easily integrate the Web 2.0 technology that the people can enjoy that. So this slide gives you an idea about the EPC application stack. And this slide shows the EPC development process. So a lot of open source projects outside, and everybody have a contribution, and choose one interest topic, and everybody to do that. We review that and to choose and package it and selection and do some integration. Just a target for our users. And then we do the platform integration. We integration the hardware platform, driver, BIOS, ACPI, because EPC has very easy to link with the hard key, soft key application enabled together. And we integrate the Linux kernel, and we have to make sure that the machine can very quickly put up. Right now it's within 1-5 seconds. And framework integration, application integration. So this is the job is done by Asus right now. And we have to do a quality test. I think that is another easy job because the application comes from a different party. Open source sometimes is Asus design the driver, some third-party design some application. We have to make sure those applications run without any issues. So we have to do the feature test, manual test, automatic test, and system test. Actually, that is a lot of Java inside. And then, after that, we produce a EOU, easy of use EPC desktop OS. Here is currently the product you see on EPC, no matter it's the software or hardware or the other feature. And we are trying to contribute our effort to open source. And this slide shows the current Linux market leaders. Actually, EPC is another Linux OS. It's just a product name, but I just identify it in some area. So EPC is identified in community Linux, and for desktop Linux, it's another for the server, it's another for the enterprise. So this picture will give you a more clear idea of what the position of EPC desktop OS. And how EPC enable with the software partner. We try to separate 4 tiers. 1, 2, 3, 4. The first tier is we call about a system partner, because sometimes we need to improve the Linux kernel, so we choose some Linux distribution partner to improve the system performance and to make the system run very stable. And tier 2 we call the application and content partner, because the EPC you can see as a mobile platform. You can integrate like education application or the telecom application to the EPC platform. So if the content provider have a value-added application, actually we also welcome them to integrate on the EPC. The tier 3 we call the web plugin application partner. You can let your application like a plugin, so the user can very easily get on the internet and plugin to install and can enjoy your application. The last one we call you are the web service partner. That is more easy to integrate because I just put the icon on the EPC and link to your website. That's almost finished. So this slide shows the integration level of engagement. That means here partner we need to identify and choose because that is about the system performance. And about the tier 2, tier 3, tier 4 is just application integration. So number of the partners means we have welcome more and more the partners from this side. And so we have a program called EPC Development Program. What is it? Actually, the mission is to complete the product by driving the platform, ensure completing the third-party software can very easily integrate to EPC platform. So we do this by providing and maintaining the API and the platform to any development. And we also support and give them the technical enable development document or solution or technical support. And we provide enough source code for value-added development. Actually, because of the technique from open source, it's a standard open source. So you also can get that by yourself from the internet. And we are trying to find a route for the EPC development because sometimes actually you have to know what the limitation on the EPC. And sometimes we will give you some experience. If you want to develop some application, then maybe you will have some technical you have to think about in advance. So we try to provide EPC SDK for third party to develop the application based on the platform and the framework. So the idea is to access a Debian application attribute. So it's based on Debian. And we have to make sure easy and safe application integrate and development. Sometimes a lot of the users, like open source developers, like to develop very interesting application, but sometimes we need to do the certification on EPC because we have to make sure the system security is no any issue, and we have to make sure if a user uses this application, then we have to make sure the system is still run very well. And we have also to need to maintain the self-run EPC brand. And right now we have very interesting to create a vertical market, especially for the education and telecommunication. So we are trying to enable those two market segment partners and those two segment developers. So this slide shows the message for the development. Asus can leverage SDK and trade vendors to open source developers to develop large developer community. And commercial vendor, I think you will appreciate the tool and the richness of the platform because you can let your application run on a different the desktop. And open source development will appreciate the familiar technology because we use the KDE. It's very familiar the development UI tool. And all developers can be encouraged to port their existing application and leverage existing skill to provide application to wide deployed consumer platform. So that is the message we show to the developer. So Asus develop OS key, it's something like that. When you install, you will have a very familiar desktop GUI. And here is a KDE ID, and this is Qt. You can develop based on that to develop very rich about the UI. And we will give a development guide and also give you a multi-language framework image because you maybe want to your application can run on different language versions. And we also give you some example. You can write a hello world. You use the C++ or Java. And Asus desktop OS development environment, SDK, right now we call it Open Circulation Edition 4.5. It's very easy to install and run on a Windows 2000 rated computer. The GUI interface is actually very friendly with Windows Live look and feel. And we also provide a compatible environment for the writing, testing, and debugging the EPC compatible application. This is IDE. This is a very familiar IDE, so we use the same, not specially, yeah. So you can use the C++ or Java, and you can, this IDE also, you can link with some plugin to support more to extend the flexibility or the performance. And you also can use the IDE to plug in a Qt4 for the UI development. So this side is Qt4. You can use a Qt to develop a multi-platform. Actually, Qt4 is a multi-platform toolkit. It's very popular in the industry. All these support Qt designer also can. If you're familiar with Qt, actually you can pull that application and run on different platforms. So just give an example of Skype is use Qt, so you can see the Skype application can run on different OS. So how to get started easily? We will provide a development guide, sample, and test environment. So the EPC document experience well for the development to know how to design the application. We try to do that, actually. It's a lot of job anyway. So, but we try to open our mind so that more development can write their existing application to put it on this EPC. VMware environment that will run on Asus Open Desktop Circulation 4.5 to allow tests in virtual EPC multi-language environment. So that is an important thing for you if you want to follow your application on different language. So this slide gives you more clear idea about the EPC application development process. These are separate two two phases. The first phase is install on the desktop. You need a development desktop, and the phase two is test it on real EPC. So on phase one on the desktop, you install the Asus desktop security software development key, and the right application use the IDE, QT4, and reference our documentation. And when you finish, you just package your application and as a Debian package and test and debug on VMware. After you done this, then you will install the application on EPC and verify application and the performance on EPC platform. And the easy to use SDK, how do we can to make sure that actually we develop on a standard desktop computer. We call that the SDK is Asus Desktop 4.5 Open Circuit, and what we can provide is a development guide, simple application, and we also can share the idea about how to document the testing and the debugging and localization. Because it's not easy job for the localization, you need a lot of things you need to do. So VMware image we need to provide for the development. So this is again, it's a more detail about how to leverage Asus experience. Actually we provide a development tips, details, platform consideration. In later slide, I will show what limitation we have right now on the EPC. And for the developer, you actually need to care about that. So for development EPC target application, first thing, you have to test that by VMware image. So the check icon is help you to check every step by step to make sure no issue for that. So first is test on EPC platform include all models, because EPC have different models. If the memory is if you choose a platform is with less memory, then you have to care more about like RAM disk, SS, the system performance. So the design idea is different from the high-end EPC. And you need to check the screen size issue. Right now, the EPC support the 800 by 480 resolution is not a standard resolution, so you have to modify your GUI interface. And you also need to test the localization in all supported language. And for example, multi-language VMware image that should be provided to you to test that. And we also can have the development more easily, but before you, we will support development to find a problem easily in the development cycle, because sometimes you miss some information, then maybe your application cannot run very smoothly on EPC. So this is a sample for development tip. So I list the table to tell you what's the difference between the standard and EPC desktop. So for your standard Linux desktop, actually you start with the INIT system. Yeah. But for the EPC, actually we already modified it. So it's a customized and the mini mail list system INIT is another full, in order to load the full INIT. So you have to care about that. And for the standard Linux desktop, you use the KDE or GNOME desktop to develop the application. Right now we use Asus desktop. It's similar, but not totally different than that. And for the standard Linux desktop, it supports multi-account, multi-user account. For the EPC, we right now only support a one-user account. It's a difference. And for standard Linux desktop, it's support a standard login, but we use the optional login. So sometimes you don't need to log in, and you can use the EPC. And here is a sample about how to develop for EPC. The first thing you have to care about is ensure the application run with minimal resource, because we have another luxury resource for the development can use a lot of memory and a lot of disk. No, we're not allowed to do that. So you have to make sure you write application with a minimal resource. Then you have to check that if it's well on both 800 by 480. We have a display which can let the EP support more high resolution, but you know it's not the default. So you have to let your application run on the default first. It's important to minimize write to the flash, you know, because it's well out after being write to 100K times. That is a hardware limitation. So if you are a developer, you want to develop application like EPC, you must care about that. And for the localization application, actually first thing is the development application to be a localized kit. Test application on all language to be supported with a multi-language VMware test environment, that's okay. So we just jump to see this toolkit. So you will use the Qt toolkit, use a KD development toolkit and easy mode. Actually, we have different mode in PC, but right now we only support easy mode on the market. But what is the easy mode? Oh, sorry. Okay, this icon base, we call it this easy mode. So more easy for user to use, so we call this mode as easy mode. It's a pure icon base. And we have another we call a full desktop mode. It's like a transition and Linux distribution. So you also can see that here. We just want to give a more exact name for the easy mode and the full desktop mode before you know what is your development environment, what is your running environment. And packaging application actually is from the Debian, so you just follow the standard Debian package. So you can very easy to package that application and just try to put it on the EPC. And the more things I want to bring up here is the delivery application. Actually, right now for the simple mode, the Asus desktop interface actually right now is use XML file. It's very easy, right? So if you are a partner like a web application partner, actually we are very easy to integrate your application on our desktop. You just write some XML file, then just put the icon here, and we can integrate your application together. And when you finish your development on your development environment, then you have to run your application on EPC. So this is a checklist for you to check your application can run on the EPC platform. So have to make sure the EPC platform for the performance and the resource usage, that is the important thing. And check the screen size issue, and test the localization in support language and the keyboards. And check the delivery and installation application, then perform the usability test and ensure easier use, because we call it the EEE experience, that make sure your application really easy to use. So then if you have an interest to develop application on it, then this slide will show how we to extend the development community. Java application actually you can run on EPC, no problem. And open source KD and the GNU Linux application also can be run on EPC. Some of the Windows application may be, can adapt to the EPC, but it's not all Windows application we can adapt to. For example, like Google Picasso, it's use the Wing library, so we can run the Windows application on Linux, no problem. And if you use the Mono and the Fortran for the Linux development, that also can be allowed to run an EPC, no problem here. And EPC provides a standard component browser environment. It's use Firefox, so you already pre-installed Java, April, Azure, and Adobe Flash Player. So this last slide is my conclusion for the EPC open to the third party. We welcome and great welcome to all development to port your existing application on our EPC platform. And what we want to do is provide you enough SDK and experience, and tell you what is the limitation when you develop application. So we need to provide a SDK to your toolkit, and maybe you can download the ID from the internet and to get enough and reach your development environment. So if you have interesting for that, you can contact Asus. Actually, we have a booth on 2 floors, and to let your application really can meet the EE experience. That is a new one, as I say, it's a new one. We want to let more and more not familiar with a PC user like a lost child can really enjoy EPC, a new technology. Okay, thanks for your time. Thank you.
So, anyone has any questions about EPC or no problem?
I have 2 questions. The first question is, what's the interface? I mean, the library interface to access your XML configuration file. And the second question is, do you have all the components to develop the PyGTK application for runtime?
Okay, this is a very pure technical question, yeah. Okay, I think not just load interface, because if you want to integrate a lot of applications, you need to know what exactly interface to integrate on it, right?
Yeah.
That is a really good question, because right now EPC is not pure open right now. So we still need to define some interface we will plan to provide, some interface we not plan to provide. So as for your question, actually I have an answer, but I cannot answer you now. Sorry for that. But you later, maybe in a few days, you can check that on our website. You will get more detailed answers. Okay.
Thank you.
Any other questions? Actually, we asked Ellis to be here, stay with us during BOF times. Also, Mike will be here. Also, we will try to discuss about maybe cooperation between EPC, OLPC, and other Linux solutions. We try to ask them to give us some other ideas of these machines. What can they do? Maybe what can EPC do? Maybe what OLPC do? Maybe what both of them cannot do, or maybe we can ask for some hackers to do some different things. Oh, I didn't say anything. For example, you saw I already changed my EPC keyboard to another model. Okay, whatever. That's another thing. We will have a little short panel after Mike's presentation. So now I don't want to speak more. So let's still give big hands to Mike for his EPC presentation.
Yeah, where is Zoom? Where is full page or Zoom? It was the one that was open. Okay. I am Mike Fletcher. I'm here to present the One Laptop for Child project. I am the developer relations coordinator for the project. We are primarily an educational project. We are not a laptop manufacturer, except that we have to be. We are trying to educate children, and our goal in the end really is to educate children. We built a laptop because when we set out, there was simply nothing that was close to what we needed. There are a lot of children worldwide who need access to education, and there's something about 75 million who are currently completely lacking access. That is, they have no school whatsoever that they can go to. About 50% of the children worldwide have no access to stable grid-based power, that is, to a wall outlet that they can plug into. Even where there are schools, even where there is a basic grid, regards to how reliable it is, a lot of the schools we're talking about are missing very basic things. They're missing desks, textbooks, paper, pencils. We're going to a lot of areas where the entire science laboratory is a stick and a stone to teach a lever and a fulcrum. We're looking at places where $20 a year is the entire education budget. That's about 1/500th of what a North American school is spending on each child. We are going into environments which are extremely hostile to traditional computers and technology. We have kids who are getting to school by getting into a boat and crossing the ocean. We have other kids who are living in the rainforest. We have others who are living in deserts. And behind all of this, many of these areas are unstable. They have political instability. They have a lot of crime. It is a very dangerous place to live. And as part of this, the schools tend to be stripped bare of anything that gets sent to them, particularly things like paper, pencils. These are saleable on the black market. So as a country spends money on their schools, the schools empty almost as fast as they can pour the money in. And this happens both with the materials and also with the teachers. As they teach the teachers realize, well, now I can move into the city and I can be more successful because there's higher salaries there, there's nicer living conditions. And so as soon as they train the teacher leaves. As soon as they put the books in, the books leave because people take them and sell them off in the city. And this is how that $20 figure has arisen. The governments look at it and say, well, there's no way we can spend on it because it just goes away as soon as we do anything. So, fixing all these problems. You can fix these problems with straightforward, long-term action. You can build out electricity grids. You can build out security for your schools so that your schools become basically a fortress so that no one can steal anything from them. You can increase the salary of the teachers over time so that the salary of the rural teacher is equivalent to that of a teacher in the city. You can build out the sanitation facilities and the like so that the teachers feel that they're living comfortably while living out in the country. But all of this is going to take a very long time. We are talking decades before you can solve all these problems. And we, as a project, want to provide services and opportunities to the children who are in school right now. We do not believe that these children should be abandoned and that only the children in 20 years should have access to this technology. Now, to solve the problem, we can't solve everything simultaneously. We have to say, we are going to try and give an opportunity to the children who are motivated, the children who want to learn. And we believe that's most children, but we can't solve all the problems. But we're going to try and give an end run so these kids can get around the problems and still have access to their future. Now, to make this happen, what you need access to almost infinite quantities of knowledge. You need access to everything society has, because your dream might be becoming an astronaut, the person next to you might want to become a bicycle repair person, the person next to them might want to become an economist. So we need access to enormous quantities of information, the kind of thing that we have in our libraries, that we have in our schools. It's always available to us. And we need to have it in such a way that it can update itself, so that you're not learning 6 years ago or 10 years ago technology, you're learning today. You're not learning the history from 15 or 20 years ago. You're actually able to learn what's going on today. And again, it all has to be off-grid capable. You have to be able to do this without power accessible to you. And in many cases, without power accessible at all. That is, it's not, you have to go to your friend's place to get power, but you simply don't have power in your village at all. So what this begins to look like is a textbook reader. It has to be something that's networked, that can update itself, that has some sort of input mechanism so that you can tell it what books you want to read. And the result is, it looks a lot like a standard laptop computer when you put all those pieces together. It has to have most of the features you would expect from a laptop just to be a good textbook reader. And once you have that, you have a lot more possibilities. You have the possibility of making it a general platform on which you can build other experiences. So it isn't just a textbook reader and access to information anymore, but it's also access to communications. It's access to expression. It's access to being able to participate in the global culture. So obviously, I mean, we are One Laptop per Child project. This is the thing we're building for these kids at the moment. We are open source philosophers, if you want to think of it that way. Everything we provide to our clients is open. We provide a hardware design that is open, that should we disappear, the country can say, okay, we're going to take over, we're going to build the thing ourselves. Okay? They don't have to rely on us, they could build it themselves. All of the software we provide them is open source. I should clarify, there are a couple drivers we haven't yet been able to get open source, but everything we are producing is open source, and we're trying to replace everything that is proprietary. And all the content we provide is open. We provide access to enormous quantities of content, and in most cases it's actually stuff that people are donating to the project. But we provide access to that so that the countries can say, well, this is what's there, we want to change it. We want to alter it, make it locally relevant, make it something that our people want to know. And again, we are an open project. Anyone at all is allowed to join. There's recently been a lot of coverage of the fact that Microsoft is part of the project. They've been part of the project for a long, long time. We allow anyone to work with us. We're not in the business of blocking people from joining. Now, our philosophy is, again, that everything we're providing is open, so Microsoft has some issues there, but we are willing to work with anyone. So one of the other key things here is that we do not know best. We are very careful, and we try to be very overt about this. We are not trying to tell people how to educate their children, and this is very key. When it comes right down to it, North American, Western educational systems are pretty broken themselves. This is something that a country has to decide how they're going to do things. And what happens is a local group in each country decides how to deploy, what to deploy, whether to deploy, first of all. And they decide what kind of rules are going to be surrounding the project in terms of how long a child has to be in school before they get a laptop of their own, how long they have to stay before they get to keep it, that kind of stuff. All of that is something that has to be culture specific. It has to be something that the country decides on what they're going to do. The other thing, and this is fairly important for us in terms of the educational world, we do not, as much as possible, try to just parachute in a solution for people. We don't try to sell this project as, well, we have a silver bullet, this will solve all of your educational problems here, hand these out to your kids and all the problems will be solved. What we do is we work with the governments, and one of the first things that we say is, look, you have to decide how this thing's going to be funded. You have to decide how this is going to happen. And the next stage is, and you also have to decide how this integrates into your school. You, again, have to decide what this is about, and you have to dedicate your energy, your time, your resources to making education and this laptop as part of it, work. And this has caused a significant ground shift for many of these countries. They're looking at this as, well, this is the point where the $20 figure can be abandoned. Right? This is the point where $20 a year, okay, it wasn't possible before, but now we can start spending. We've all recognized that education is important. I mean, every country understands education is their future. And they are now saying, and now we can spend. Now we can actually invest in our children and move forward. So the hardware we've built targets the backwards 50%. Okay? This is that key thing about the hardware we built here. We built it for the kids who are off-grid. When it comes right down to it, it's a little over-designed for the kids who have electricity everywhere ubiquitously with no need whatsoever for a 6 or 7 hour battery life. It is designed for the kids who are in the exotic environments, who are in the deserts, who are in the rainforests, who are working in situations where your standard laptop is basically going to fall apart in a few weeks. And as we've done that, we've actually created a very cool laptop for those who do happen to have all the neat resources. I mean, it does have extremely long battery life, and we're working on getting that to go even further. But one of the key things that we've done, and that is sort of unique about it, is this 200 dpi screen that's on the laptops. Again, a lot of our students don't have schools. Okay, there's no building that they go to that is their school. So they're reading outside, and a lot of our kids, even who do have schools, still wind up reading outside. And what the screen, I didn't even ask how familiar people are with the screen. The screen is 200 dpi, it's dual mode, so under direct sunlight, it becomes a 200 dpi black and white display. Extremely high resolution, very nice contrast under direct sunlight. Under interior conditions, you can turn on a backlight and it becomes a normal color screen with regular resolution. But the nice thing about this is, it is our most common usage scenario. That external textbook reader scenario is also our most efficient scenario. It allows us to completely turn off the backlight and get very, very long battery life. I believe we're currently running about 10 hours in this mode on the current software and hardware, and we're hoping to get that up into the order of 24 hours or so. Other interesting things there, we do have a fairly low power envelope. At the moment, we're below 2 watts. We're trying very hard to get that below 1 watt. We would love to be able to get that down to half a watt on average. Now, our processor all by itself chews up 0.8 watts. So when we're going there, we're going to be looking at very aggressive sleep situations. Our final target is to get to the point where if you have very long keystrokes, if you're typing fairly slowly, the machine can go to sleep and wake up again between keystrokes. Okay, that is our eventual goal in terms of our power savings. And there's special hardware on our laptops to allow that. When we go to sleep, there's no visual indication that we've gone to sleep, because we have separate power rails for the display controller and the main CPU. But that is our eventual goal. And when we get to that sub 1 watt, sub half watt if possible, we're getting down to the point where we are talking about days in plural of usability with a single charge. And for these kids who don't have grid power, that's very important. What that very low power signature allows is it allows us to use alternative charging technologies, things that are largely impractical, well, they're totally impractical for any normal laptop rather. We are able to use mechanical chargers. This is actually just a computer graphic of it. The product on the right is from a company called Potenco. Theirs is a flywheel style device. It gets about 1 minute to 10 minutes charging potential with the current machines. The one on the left there is from a company called Free Play. it's just basically a huge crank that you attach onto a desktop, and it produces I think it's slightly more power if I'm not mistaken. But we also are able to use very cheap solar cells. A solar cell to power this laptop costs about $10. Okay, so it's a significant fraction of the cost of the laptop, but it does give you that free energy, effectively. And those are just solar cells that were originally intended for charging your cell phone. Because our power signature is so low, we can start working with those kind of cell phone level technologies that way. And then we have, of course, the more infrastructure level stuff. You can hook up any generator to your windmill, your water mill, your oxen, your cows, your almost anything you've got. You can probably connect it up to these things. They have a fairly wide range of power they'll accept, so you can hook it up to your car battery, your motorcycle battery, and get the power out of it and be able to use it. The battery we actually have on there is lithium polymer battery. It's non-toxic. It's one of its key issues for us. These are things that are going to be in the environment and potentially thrown out. We're very concerned that we not have lead or arsenic or anything of that type in our PCs, because we don't want to be polluting the third world as we give them these things. It is reasonably resilient. My laptop has now been dropped approximately 5 times onto concrete. You can break them though. If you drop them in certain ways, you can actually knock pieces off or break the screen or that kind of thing. In Nigeria, I believe they have a laptop dropping every 20 minutes in their school. They just simply have very high-angle desks, and so whenever a kid knocks it, it jumps off and drops onto the floor. With that kind of frequency of dropping, it tends to be damaged. One of the key design requirements for us is that the children in the towns should be able to repair this laptop. That is, with a single screwdriver, they should be able to pull it apart, repair anything that is likely to be repairable, put it back together, and keep using it. And that includes everything from replacing the screen, replacing the motherboard, replacing the little ears, the antenna. All of these are things that the children need to be able to do so they can have a 5 to 10 year life cycle on these computers. The software we run will seem familiar after the last presentation. We are a Linux-based system. We use open firmware as our BIOS-like system. A lot of our security systems are actually built into the open firmware level, and a lot of those are theft deterrents and the like. On top of that, we have standard GNU Linux. It's actually Fedora 7 for those who are really into Linux. We have GTK rather than a Qt base on our system. We have Cairo Pango, all these wonderful things. XUL runner, that's Mozilla, for those of you who aren't familiar with the underlying technology. AbiWord is a word processor. I guess it'd be like 3rd or 4th most popular open source one. And Csound is an acoustic modeling system, very similar to what MIDI does, except it allows it to do it with an algorithmic definition of what an instrument should sound like. And we'll get to why that's important later. The shell, the interface that you see, very similar to the easy interface, is designed for a concrete operational learner. Concrete operational is an educational term, meaning, well, I'll just give you the ages. Basically, 7 to 11 approximately is the ages for a concrete operational learner. They're characterized by certain restrictions on what they're able to do compared to what an adult is able to do. Now, this is what the Sugar interface looks like. You got the network zoom, your buddy's off the left, your clipboard shows up buddies are on the right, clipboard on the left. The activities in the middle, and then, activities running, and then the activities available. The interface is very straightforward. It has a minimum of things going on simultaneously. Okay, that's one of the key things for reducing the complexity for a child. But it is a fairly straightforward system to run in terms of getting around it, navigating. To navigate, you always come back to your home window and then go back into where you were. It's always a 2-step process for them. There is no flipping quickly between between activities until you know the keystroke. Once you've learned that, you can do it, but there's no graphical quick switch between them. This is what our web browser looks like. Again, this is it's Firefox in the middle for all intents and purposes, but we've got a very much simplified interface for the children to use in terms of the navigation and what's going on. It is designed to be a very simple experience for running, and it is designed to have just the features they actually need, with the rest of them being addable over time as they need it. This is the PDF viewer. It is, again, designed to be very simple. Again, textbook reading, very important feature for us. So the textbook reader has to be reasonably capable. This is actually a project called eVince, which is a PDF and textbook reader from the open source community. This is our news reader. The news reading software is primarily of interest for things such as, well, obviously news, but also things like your homework assignments, your enhancement material assignments, so the extra reading from your teacher. This is the kind of stuff where when the child is at school and has network connectivity, they download all the series they need by opening up their newsreader. They go home, they can read what they've downloaded offline, and they can get that material while they don't have a network connection. This is the AbiWord text editor that I described earlier. As you can see, very much simplified interface compared to your normal word processor. It is designed to be used by 6-year-olds to 7-year-olds. This version is basically 6-year-old to 7-year-old understanding. It is still our most complex application, as far as I recall from our UE. These little tabs you're seeing underneath the bar, those are actually all button bars. So by far our most complex interface in terms of requiring a lot of work to get into the more advanced features. It opens up with just the basic features of writing text, but over time, as you learn how to do tables and images and all the rest, you get a lot more complexity available. This is kids playing around in the text editor, and me and a couple of other people as well. It is entirely networked, and that is very important. All of our applications, everything that we deliver, is network capable, and it is collaborative, right? So our text editor is collaborative, our word processor, our web browser is collaborative. Everything that we provide the children, they can do together across the network. That includes the audio synthesis, all of it is together. This is the audio synthesis application. It's called TamTam, by the way. It allows the children to play music on their laptops, either together or alone, and to record off a score of what they've created. They can then record that, share the score with other people. They can go in, they can edit the score. It's a very involved music synthesis system, and it all runs on top of that C-Sound library I mentioned earlier. So it allows us, with a very small footprint, to produce an enormous number of fairly high-quality instruments. MIDI, by comparison, requires a lot of samples to create a high-quality instrument database. So it takes a lot of bits, a lot of flash space in our case. With TamTam, we're able to do a lot of very high-quality audio without that restriction on space. This is a multimedia environment. It is called eToys. For those of you who are programmers, it is the language Smalltalk from 20 or 30 years ago now. Smalltalk has just an enormous amount of educational content available. I mean, it's 20 or 30 years of research into educating children. So the teachers rather are able to download an enormous amount of pre-prepared material for how to teach this, that, or the other thing, and use the environment to have an educational plan. Other things we include in the box, we do include a video camera. It's a standard webcam type video camera, about 640 by 480, 330 frames per second rather. It also, of course, functions as a still camera. We have a reporter activity, which is designed to allow the children to report on what's going on in their lives. It's backed up by a website, and the teachers can promote certain assignments up to the website so that they now have basically global exposure among all the children in the project. This video here is actually from a 10-year-old child in Uruguay. She taped a cow being born. It's really quite gross. It takes 20 to 30 minutes. It's quite touching, but yeah, it's really gross. This is one of the things that really excited me when I first got into the project. The laptop is designed for learners from the ground up. So with a few truly trivial alterations, we've been able to add a lot of very cool features. The probes here, the audio port on the laptop rather, has a few extra little features, trivial features though. But what they allow us to do is to create probes such as water quality, air quality, volt meters, amp meters, all the kind of standard scientific tools that we have in our high school classrooms. And we can create all these tools for around $1 each. So if you consider for the price of basically one laptop, you can have a chest with 200 or so instruments in it. And this can then be something that is in the school, the children can sign out a given instrument, and they can wander around the countryside poking into things, seeing how their world actually works interactively. The microscope is one of those. This attaches onto your video camera and gives you a networked shareable video microscope, which, I mean, honestly, is pretty cool. I never had one of those when I was a kid. We do have games for the system. We are constructivist learning philosophers, whatever you want to call us. We do believe that engaging play is part of learning. And this application here is actually the X11 version of SimCity. SimCity is being ported to the laptop. I am actually going to be working with a group next weekend on creating a very simplified real-time strategy game for the children. Very basic, somewhere between chess and SimCity in terms of its complexity of interface. And we're going to be looking at a lot more games in terms of things that are educational in the sense that they teach you something, they teach you strategic thought, they teach you how to think about something, but not edutainment, okay? A lot of the things we see, particularly in the Windows educational market, are entertaining in that they play, little bleeps and bloops as you do things, but the fundamental gameplay, the fundamental thing that you're doing is not related to the entertainment part of it. We believe very strongly that it should be the play itself that teaches, and that is the kind of games that we're trying to provide for the countries. Now, I mentioned that the kids wander around the countryside poking at things. The world is dangerous. As I mentioned, a lot of these kids are living in environments that are not friendly. We have to have a far more involved security protocol than, well, almost any laptop. I guess maybe the NSA has more involved ones, but we need these laptops to be something that a 6-year-old who can't read can maintain securely while allowing them to download new software, to alter the software they're currently working. We have extremely high security requirements on it, and the result is that our protocol is currently probably the most advanced security protocol for any desktop computer on the planet. One of the challenges we're going to be having over the next couple of months is trying to get it into other Linux desktops and laptop systems. It is invasive. This is one of the things about NICFrost. It requires rewriting your applications in many cases. It's not a complete rewrite, but it requires altering core functionality. And that's something that's a bit of a deterrent for people. Anyway, one of the things it allows us to do, however, is we do have automatic backup and journaling. So the kids do not lose their work. The laptop has about a gigabyte of flash RAM on, well, actually it's exactly a gigabyte of flash RAM on there. We use that primarily as a cache. Everything that's on the laptop is just a cache of what you've been working on recently. The school server and the backup servers that are global or national are storing the actual long-term images of what you want to keep. And as soon as you go to school, your laptop backs itself off on an encrypted image to the school, and then again up to the global backup servers. So the the cache that's on there is not really important. And if you lose your laptop, you don't lose your work. And that is very important for our use cases, because these things are going to get lost. They may get stolen. Someone may decide to steal one for parts, despite the fact that it's going to turn itself off, turn itself into a brick, basically. It may happen. You need to be able to recover well from it. In terms of the school level components, I mentioned that the school does provide the backup service. It also provides network connectivity. Every country we're going into has agreed network connectivity is key. So the schools are being connected. It's often not as much bandwidth as the kids would like. Amazingly enough, 600 kids all watching YouTube takes a lot of bandwidth if you're on a satellite connection. But anyway, they are getting network connectivity. It also provides caching, proxying, all that kind of common things you would expect. And it provides registration facilities, that kind of standard running a school type operation. The content is extensive. One of the things that's occurring, because we have such a high-profile project, we have large numbers of groups coming up and saying, we would like to get our content into your system. So we get universities saying, send a curator over, just take whatever you want, carte blanche, we'll give you license to whatever you need. We have content groups whose entire job is collecting content who are saying similar things. We are getting every once in a while interest from media companies who are saying, we'd like to figure out how to make it happen. I don't think we've actually had any of them commit to making everything open yet, though. But again, a country can decide to relate with one of these groups and get content for their kids reasonably well, or reasonably easily. So, moving forward, what we are looking for in terms of our development community and how we're going to move the project forward. We want to get the open educational projects working together. And we have to admit some fault here. We've been pretty bad at integrating with other people's projects. Mostly that's because we've been focusing on actually getting something, and this is what we came up with, to address that 50% who doesn't have access to electricity. That's been our primary focus. We're launching this month, so we're done that part. We've got the basic machine there. Now we need to move forward and say, okay, for the other solutions, the solutions that can plug into a grid, the lab-based solutions like the thin client systems from Ubuntu, for all of these kind of systems, we want them to start working together so that we've got compatible applications, so that we're working with the same content stream, so that all these people who are offering us huge amounts of content can get onto all of the content projects, all of the educational projects, and the kids who are using them can all work together on digesting and filtering through the information. Next one is fairly key for us. We'd like to get out of the laptop business. We don't want to be building laptops forever. We are educators. We want to be able to go to manufacturers when we want to make the second iteration and say, here are the parameters. We need something that has 2 days battery life for generation 2. We need something that is sunlight readable. We need something that has ubiquitous Wi-Fi, or maybe by that time it's WiMAX. We would like to get to that point so that we no longer have to build these things, because quite frankly, it's not educating kids. It's not what we actually want to be doing, which is working on the educational aspect. We need to reduce our porting effort. This is something I'm personally interested in working on. As I mentioned, Bitfrost is requiring quite a few changes. We'll run any GTK or Linux application, but it doesn't integrate well. We want to get to the point where integration is simply a matter of writing a script or writing even just a desktop equivalent file that says, this is what our application is, these are the directories it's going to be writing to, this is how we store it and restore it. Again, part of that is making Bitfrost more generally usable. We want Bitfrost to get to the point where every Linux desktop and laptop has it on it. There are some things that need to change about Bitfrost to make that happen. because right now it dictates a little too much. We're going to try and make that something that can go anywhere, that can work in any way. And we would like to redefine laptop. We would like to make the constraints on what a laptop can do and what a laptop is about explode. We would like to get to that point where, you know, it's basically a device for accessing information, and it's not about necessarily computing and technology. It's simply a way to get to where we want to go. Again, we are an open community where anyone at all can join us, whether corporate or individual. We are looking for developers actively. The way you join is you simply join the mailing lists, you start talking. We are quite willing to direct people to certain projects. We have people whose job is to basically place you with a project. And act, make things, and we will see what we can integrate and what needs to still remain external but be available. And thank you, Pat.
So, any questions? Oh, sister. Oh, no? Yes or no? Really? What things?
So you mentioned this bit frost, it's invasive, so a little bit about
Oh, my IP.
The question was, how is Bitfrost invasive? Well, the key thing about Bitfrost is it restricts where you can write files, first of all. It also restricts, currently, it requires you to write your files that you want to save via a special API to the journal, right? So it is not automatic that when you write a file, it gets picked up by the journal. So as a result, when you are porting things into the system, you have to rewrite every file access operation to now call a different API than you've been doing. It's a fairly mechanical translation, but it is a rewriting. Like, it requires going through and changing code and then recompiling the whole thing. What we would like is we'd like the ability to still do that, to still be able to directly write to the journal and use all the advanced APIs there. We'd also like it to be possible to simply describe, for instance, Thunderbird as, well, this application has a directory where it stores persistent data, that is your mail, and it has a directory where it stores its configuration, and restore those when, like, consider that the journal entry. When it writes there, that has to be stored, and here's the strategy you should use for storing it, because you don't want to store your entire mail directory every time in the journal. But that requires a little more programming inside Bitfrost. In terms of the other stuff it does, you're restricted from grabbing the mouse pointer. You cannot grab the mouse pointer and start manipulating the mouse in Bitfrost. That's a simple security precaution. In any regular desktop application, if you can grab the mouse pointer, well, you've now been given all of the privileges of the current user, because you can simply start clicking on things and give yourself whatever privilege you want. There are other restrictions in terms of direct access to the X server connection. There are network access restrictions that can be placed on you, audio access, camera access. All of these things are, if you want access to these extra features, you have to have a tiny little bit of programming in each case. And that is by design. It is to protect the children from being spied on. It's to protect them from being, from their computer being subverted. But it does mean that an application, such as a web chat application, is now going to have to be rewritten. Well, it's going to have to be written or marked, depending on how far along we are on this process, so that it can say, I need access to your camera, right? And what happens is you can't just turn on the camera on the laptop. You can request that the camera be turned on. The user is asked if they want to let you turn on the camera, and that happens outside of your application. And it's only if they say yes that the camera actually turns on. The same thing with the microphone. These are all security precautions that are basically to avoid people spying on the kids or taking advantage of them.
So any other questions? If there is no question, I have one question for our two speakers, since they all have cute laptop. Maybe Asus said that is not a laptop. That is an easy computer, right? Somebody said, oh, this is not, come on, this is not laptop just because there's no warranty life laptop. That's another problem. That's not my question. My question is, these two laptops are both for children. So how can you help those children who are not speaking English, French, or understand this kind of keyboard? Or of course, Asus is only hardware developer and maybe manufacturer and also with some applications. But for educator here, I think there must be some different ideas about that. And also, I'd like to ask both of you, if you have any chance to be cooperate with each other about contents or software or something like that.
Okay, first question, localization. We are fully localized everywhere we go. Our keyboards are custom for each country. We have the Nepalese, I forget all of them now. We have, it's custom for each country. They decide what keyboard they want. We have Aramaic at the very least, Urdu, and they're all just, it's just a silk screening across the keyboard, so it takes almost no effort. Second question, is there opportunity for working together? I would hope so. I mean, that's sort of why I came here. So, yeah.
Actually, I want to point out one thing is this EPC is designed for not just for a child. Actually, we position this EPC for thread-aware PC. That means keep you very easy to carry out to do something. So it's a multi-function notebook for the people like children, outside sales, housewife. So the package is different. All of it is very dedicated for the education and to education in the country like under development. So the package is different. For the localization, actually, because we are PC manufacturer, so we provide different keyboard. That's no doubt we can provide the local language different keyboard for customer. And the second thing is the cooperation. Of course, we get a very benefit from the open source. Actually, we also need to contribution back to them. And OLPC is very, very great educating software. That's also help our customer or help people, help children. Why not we cannot cooperate together? So that is our idea. Thank you.
Since I have about 5 minutes or 6 minutes time, I have last question before we can go out to somebody maybe wants to go to the bathroom just because it's 1:30 station. So the last question is, most of the people here, the audience are hackers. It means if they like to modify something, include software and hardware. So as we know, here we got warranty. We got warranty seal here. So it means we cannot modify anything except keyboard. Keyboard I can change. That's easy, but we cannot do anything else. But also somebody has some different idea of this machine. Maybe, especially Microsoft, they want to install their operating system here, right? So we'd like to know if we can do anything by this hardware. Maybe we modify the disk to to hard disk, or maybe we can add something inside. Maybe we can add more memories or something like that. Maybe we can change our software to for network administrator use, or maybe for POSIX and point of sale system or something like that. We have some other people discuss about it, and with help of Asus. Really.
Actually, it combines a lot of questions. One thing is the hacker. Actually, we usually appreciate the hackers because they will push us to improve our product every time. Okay, the EPC combine the BIOS, driver, kernel, application. That's a lot of job. Actually, we cannot care about everything very well. That's true. So we need to open something for the development to do something. Now that is why we choose the open source, because everybody contribution their efforts on that application that will keep us move. That's I think that's the most things. Maybe you can see the news from television or other product category. Actually, EPC also can a lot of people to upgrade to the SP. Actually, you can treat us as a general network. You can upgrade any application you want, include the OS. So you can upgrade to the SP, you can upgrade to other things. But the modification, maybe you need to take some care. It's, maybe you want to extend memory, you want to extend storage. So we have the limited resource. We allow you to do the limited to expand the hardware. For example, if you want to extend your storage, you can use a USB hard disk. Or you can open the door on the back to get a memory more to expand that. But my boss don't allow me to say that. You need to have a label put on here. So if you open it, that means no guarantee, right? But we are the development, we are like to try everything. So actually we still want to keep an open mind. A lot of people do more things than this. Okay, thanks.
Okay, so now it's 2:28 and we have about 12 minutes to have a rest. And thanks our speakers, and come back 12 minutes later. Thank you very much.